In this video, I'm going to discuss the MATLAB modeling of three-phase inverter. I have already discussed the working of three-phase inverter with different modes of operation. So in this video, let me discuss how to develop MATLAB code in the modeling of three-phase inverter. First, you are supposed to define the parameters which are relevant for like the inverter. Probably we have input voltage, then the expected frequency, etc. Then you need to mention about switching pattern. We already studied two modes of conduction. One is 120-degree, other one is 180-degree. So you need to define the switching pattern for 120-degree mode. Okay. So that is the second step. Third step belongs to the setting up of 180-degree mode of conduction. Similarly, you need to generate the phase voltage. We have separate function for that. Using the switching patterns, create the waveform for each phase. Last step is to plot the waveforms. So we'll be having a better visualization for observing those waveforms. So these are the 5 important steps. Okay, now you can develop the program based upon these steps. So before that, you need to study some important functions which will be helpful for making the function. So one of the important function, as you can see, the function called mode. Okay, mode is a built-in function. It is used to repeat the conduction pattern in the periodic fashion over multiple cycles. So that's a peculiarity of mode function. Similarly, we have facility for ensuring the phase offset. Here, each phase conduction period has been by 120-degree, or what we can say is 1/3 of the total period of repetitive each other. So that's what we are going to mention the phase offset. To be frank, we have expanded time range. Okay, now we need to plot the multiple cycles. So it will help to have a better visualization because we need to show the period we need to show the waveforms in a periodic fashion. So we are going to go for proceed with the expanded time range. These are the important points you need to consider. Okay, so we have discussed about algorithm. Now, important functions which are required for the program development. Another one is actually setting of parameters, explanation. So the first step I already told you that you have to define the parameters. So say we can have the input voltage of 100 volt. Then to arrange the 120-degree conduction mode, like you need to understand the pattern. Okay, interval will be like 0 to 60 and 180 to 240-degree. If you want, you can convert into radian also. That is up to you. Similarly, first of all, better understanding in terms of degree. Of course, we need to convert in terms of radian. Similarly, for phase B and C, it will be like a particular cycle. Okay, so you have to design the mode of conduction in this particular sequence. Now, if I talk about like a 120-degree conduction, phase A conducts at 180-degree, phase B will be conducting 60-degree later. For example, 60-degree to 240. Then phase C will be starting from 120-degree to 300-degree. That you have to remember. Then plotting. Plotting will be the last step. Okay. Now I'll be showing you the MATLAB code. So first of all, you have to open the MATLAB. Okay. So now let us share the screen. Now we can see parameters here, like input voltage and the time sequence. I'm going to define the time sequence in this fashion. First of all, I'm going to focus on 120-degree conduction mode. Here I'll be using the formula. So please take care of the formula with the mode function. Like it is for phase A. Similarly, I'll be writing for phase B, equation for phase B, and similarly equation for phase C. Those equations you need to convert in the form of like a programming. Similarly, I'll be going for like a 180-degree conduction mode. Here also you need to focus about the formulas. Correct, no? VA underscore 180, that is VDC into mode of T comma 1/3 less than 1/2. Okay, so like that you have to mention phase B and phase C. Then I'll be plotting, so creating the figure for 120-degree conduction. I would like to go for like a plotting. Okay, so you know the meaning of subplot, correct? Okay, so subplot 1 comma 2 comma 1 comma 1. So I'll be focusing on the first figure. Similarly, I'll be going for another waveforms. Okay, then ultimately I need to go for X labeling and Y labeling, title, all the things, and setting of axis properties. Then while talking about 120-degree conduction, I need to go for like plotting of uh, phase A and phase B, phase C, all the things I need to plot. Here I'll be using the same condition as that of 180-degree 120-degree conduction. All right. So I'll be just plotting the waveforms of 120-degree conduction as well as 180-degree conduction. So this is a major important lines of the program. You can use the different type of variables. There is no problem. So have a look on this. Now I'll be going for running the program. Let me run the program. Okay, I have run the program. Okay, now I'll be taking you the waveforms. Let me share the screen. So while talking about the waveforms, yes, I have obtained the waveforms for 120-degree and 180-degree conduction. You can observe like how the conduction is getting varied. So in this session, we discussed about how to develop the MATLAB code for three-phase inverter. And initially we discussed the algorithm, then important function. Later, like the different detailed steps of the program development. Even I have done the coding also. You can have a look on this. Same program you can develop and you can obtain the waveforms. If you have any clarification, so please do let me know. So thank you for listening this video. Happy learning. Have a great day.